Hi, welcome to our next junior relations video. We're going to use this video to show you how to find the algebraic rule for a linear sequence. Right, well, linear sequences use the following algebraic rule. Y is equal to m times x plus c. We'll explain what m and c are soon, but that gets abbreviated, shortened down to y equal to mx plus c. It's a very useful and important formula as we move on with our mathematics. Here's example 1. Find the algebraic rule for the following sequence. So the sequence starts at 5 to 8 to 11 to 14 to 17. Hope you figured out quickly that we add 3. We'll come back to that soon. Now this is the rule that we're going to use. Y is equal to mx plus c. So I've drawn up a table here. You can see that the first number, which is x, the first number is equal to 5. The second number is equal to 8. The third number is equal to 11. The fourth number is 14. The fifth number is 17. So x represents what number we are, and y represents the actual value of the number. All right, now we discovered that we add 3 in this pattern. We start at 5 plus 3 plus 3 plus 3, right? That's what we figured out. So as soon as we know that we're adding 3, we know straight away 3 is equal to m. M is equal to 3. So we can write down the first bit of the rule, y is equal to 3x plus c. We figured out m is 3. M is what we add on to get to the next number, or sometimes if we take off, what we subtract. Right, now we're going to go to what's called the zeroth term. This is the number before the sequence starts, when x is 0. Now we're going to figure out what y value will be there. Now it's going to be 2. Why 2? Because we know we're adding 3. So 2 plus 3 gets us up to 5. So that value of y is, when x is 0, is 2. Now once we've got that value, that becomes our value of c. So c is equal to 2. So we've finished. We've come up with our algebra rule. Here it is here. Y is equal to 3x plus 2. That is the algebra rule for this pattern of numbers. Right, we're going to go and check it. So when x is 1, which is the first number in the pattern, we're going to substitute 1 in for x. So we're going to go 3 times 1 plus 2 more. 3 times 1 is 3, plus 2 more makes 5. Yep, that's the value for the first term. When x is 2, we're going to go 3 times 2 is 6, plus 2 more makes 8. Yep, that's the value when it's the second term. What about the third term? So when x is 3, we're going to go 3 times 3, which is 9, plus 2 more is 11. Yep, that works. And so on. So what would the sixth value be? Well, I haven't drawn it on the table. I can pretty quickly see that the sixth number should be 20, but let's check it works in the rule. So the sixth number, 3 times 6 is 18, plus 2 more makes 20. So the rule does work. Now we can use the rule to work out like the 50th number. We just need to say, if we want to know the 50th number in the pattern, we just go 3 times 50, which is 150, plus 2 more, giving us 152. Right, let's move on to a second example and do it all over again. Find the algebraic rule for the following sequence: 3, 7, 11, 15, 19. So have you figured out that we plus 4? Right, let's write down this rule that we're going to use. Y equal to mx plus c. Let's bring up our table. Remember, the first number in the pattern is 3, the second number in the pattern is 7, the third number in the pattern is 11, and so on, right? Right, we know that we add 4. I said that about 20 seconds ago. So as soon as we figured out we add 4, that becomes the value of m. So the rule is y equal to 4x plus c. Now we go to what's called the zeroth term, the number before the pattern starts, and that's going to be -1. Now that's a bit tricky. Why -1? Because -1 plus 4 more brings us up to 3. Right, so that's C, -1. But remember that plus and that minus, 4x plus -1, the plus and the minus just becomes a -1. So the rule is y equal to 4x minus 1. Quick check it works. 4 times 1 minus 1 gives us 3 for the first number. 4 times 2 minus 1 is 7 for the second number. 4 times 3 minus 1 for the third. It's all working good. And we could now work out the 99th number if we felt like it by substituting in 99. All right. Hey, thanks for watching.